All right, so the x's you told me in the top, how many would be left in the top? 1. Good. How about the y? 3 in the bottom. Z's? 3 on the bottom. Any problems with that on the x, y's, and the z's? Okay, what is the common factor on 6? Yeah. So negative 24 divided by 6 is negative 4, and 18 divided by 6 is 3. That is our answer. Anna?
Why are the exponents negative?
Never put them negative. That would be a wrong answer.
So you're not supposed to like subtract it?
We did, but we always subtract smaller from larger. So if the larger's exponent's up top, that's where the variable is, and just go 3 minus 2. The larger exponent was in the bottom for the y, so you go 4 minus 1, you get 3. And 5 minus 2, you get 3. That way we don't have any negative exponents when we're finished. Okay? What do we do for the one on the right there, the radical? Isabella?
I was trying to get a radical formula.
Okay. Why did you do that?
I don't know.
Why do we do that? Yeah, we can't have a radical in the denominator, so we have to do that. It's called rationalizing the denominator. Okay? So what I would do, check first though. My first check is to see if something goes into both of those, right? Reduce that fraction. But we can't, right? So we do what Isabella said. Now, what I did, so I don't have a big number, 18 times 7 is a big number. Not too big, but it's kind of big. I went and did a factor tree for 18. And what could I pull out of there? A 3, right? Now, on the last quiz, a few of you realized that that was a 9, but you pulled the 2 out and left the 9 under there. Remember, the perfect square is the one you take the square root of, right? The square root of 9 is 3, so the 3 comes out front. So then I have a 2 under there and a 7, so this becomes 14, right? So that's what it should be when you're done. Okay, you cannot divide the 7 now that's outside the radical sign into the 14 because it's under the radical sign, right? Okay, but if you just did 18 times 7 and got what, 126, is that what it was? And then factored the 126 to 3 radical 14, that's okay. But I just try to do it sooner, so I had smaller numbers. I just had to multiply 2 times 7 instead of 18 times 7. Those two make sense? Okay, good. So, answers to our practice quiz. Okay, so our first picture, our graph, looks something like that. And its question says, which is an element of the range of the graph function? So the range is what value? The y value, right? What do we call the x value? Domain, right? So the y values of, here's 2, and then 4, 5, 6, right? So there's 1, 2, 3, 4, 5, 6, right? So looking at this graph, which one of those four numbers is part of the range of this graph. The 2, right? Because there's a point here, looks like 2, 2 for both. I don't know if that's right, but just on my picture. So there's 2 y values of 2 ranges, right? These points are not anywhere. There's no 4, 5, or 6 on for the y value on this graph. It's called a parabola, actually, when it's curved like that, up and down or up. Okay, we'll talk a lot about those things here pretty soon for the parabolas. Does that make sense, that problem? What if I asked you the domain of this? What's the domain? Put it in interval notation for me. No. That's a good guess, though. No. Bigger. What's happening to this? What's that telling you? It's going down, right? And it's getting wider, right? Expanding like Hunter said. Oh. So, what? We're going from what to what? Yeah, infinity to negative infinity, right? All real numbers. So in interval notation, it'd be like that, right? For the domain. Just something to think about. Maybe I'll ask about domain tomorrow instead of range. All parabolas domain is all real numbers from negative infinity to infinity. Interval notation for that set of numbers, that inequality. All right, so it says -1 less or equal to x less than or equal to 9. So when we have equal to, we're including the number, we use the brackets, not the parentheses. So for interval notation, you use parentheses or brackets, or one of each, depending on if you're including the number or not. Bracket includes, parentheses does not. Number 3, you're given a graph, a picture of some answers, and you're supposed to represent it in set builder notation. So you make a set brace, X, and a line, it means such that. That's how you always start set builder notation. And then you write an inequality for the picture. So we got -4. Are we including the -4? Yes. So we got the less than or equal to. Are we including the 2? No, so it's just less than. And then close it up with your set brace. Okay, number 4 is really easy, but I get kids every year that miss these. Okay, so our number is 8/9. Okay? The additive inverse, think of opposite. Multiplicative inverse, think of reciprocal. Okay? So what's the opposite of positive 8/9? Negative 8/9. That's the additive inverse. Okay? What's the reciprocal of positive 8/9? 9/8. That's the multiplicative inverse. Okay? So for multiplicative, if it starts out negative, it's going to stay negative. For additive, if it's negative, you make it positive. If it's positive, make it negative. Okay? Don't confuse those. Right? It's an easy problem. Just not paying attention to details. Okay, property. All right. All right, what did they do? What property did they use? The distributive property. You guys all recognize that, right? That's an easy one. What are the other 2 possible answer problems? Commutative and associative, right? Commutative has to do with changing what from one side to the other? Order, right? So this is distributive. All right, commutative changes order. It could be multiplication, addition, or, I guess I shouldn't do that because that looks like division sometimes, right? So, if I had 2 plus 3 equals 3 plus 2, you would write commutative property of addition. Again, you don't have to write that all out. You can put COMM like I do and do a plus sign for addition. Okay? If it was 4 times 5 equals 5 times 4, you would tell me commutative property of multiplication. If you don't put addition or multiplication for commutative or associative, you're not going to get full credit. All right? That's part of it. Okay? Associative has to do with the grouping. What's grouped? Again, addition or multiplication. Okay? That would be like A plus B in parentheses plus C equals A plus in parentheses B plus C. Order is exactly the same. The parentheses, A and B was in the parentheses on the left, B and C is in the parentheses on the right. So that would be, since I used addition, associative property of addition. Okay? So those are probably the three you'll see. If it's closure, you'll just have an either addition, subtraction, multiplication, division problem of 2 numbers equals some number. Closure means if I multiply 2 numbers, I get the same type of number. And if I multiply 2 real numbers, I'll get a real number. So real numbers are closed for multiplication. So it could be closure, but I hope it isn't. It's probably distributive, commutative, or associative. Number 6, another square root problem. And we have a fraction. So this is a little different than the warm-up because what can you do to this? You can simplify it. What goes into both of those? 2, right? And if you divide them both by 2, you get 49 over 64, which are nice numbers. Why? Because they're perfect squares. What's the square root of 49? And 64? 8. No radical anymore. Because they were perfect squares, the radical sign's gone. Every year, you get a few that'll put square root of 7/8 or square root of whatever it is.
I got the right answer, but I think it was from luck. Could, after you go over this, could we do a problem that's like this so that I can go to filter again?
Yeah, sure. Okay, I do not want the decimal answer. Don't just put that in your calculator and give me the decimal. You won't get any credit for that. Okay? That means you haven't been paying attention on that. Yes, on.
Okay.
Was that quick enough?
Yeah, good.
That was enough?
Yeah.
I was trying to be mean to you, and it wasn't even mean to you. I should try to do that for sure. Should always be nice, right? Be kind to each other. So, I got another radical one. Can I divide is there a number I can divide into 3 and 5? No. So I do like we did on the warm-up. Just rationalize the denominator. So I get the square root of 15 for the top, but what does the bottom become? 3. Now, I saw a few, this is it. That's the answer. I saw a few people that turned it into the square root of 5. Is that correct? No, I cannot divide that 3 into that 15 now. Because they're not both under the radical sign or both outside the radical sign. Number 8. Can I subtract those 2 radicals? Yes. Why? Like radicals, yeah. Same idea. You need a common denominator for fractions. You need a common radical for radicals. So, if they weren't the same, what should I try to do first? Simplify them using your factor tree and make them the same, and then you'll be able to add or subtract. Right, Derek? Yeah. So what is 7 minus 20, Derek?
That is 13.
Close.
Negative 13.
Very good, sir. Okay, don't forget about your signs. Little details. Again, sometimes we get in a hurry and we make careless mistakes. So let's try to eliminate the careless mistakes. All right, write an algebraic expression to represent the number of letters Aaron wrote. Aaron wrote 7 letters to friends each month for n months in a row. So if I said Aaron wrote 7 letters to friends each month for 2 months in a row, how many letters would you write? 14. What'd you do with the 7 and the 2? Multiply. So if you're not sure what to do, plug a number in for the letter, and usually you can figure it out real quick in your head. We'll just think about what you did. So number 9 is just 7 times n, or 7n. Number 10, this is really tough. T plus v. T is 4. V is 2. So you get 8, right? All right. Again, don't make careless mistakes. Number 11. We're just simplifying the expression. We've got an s squared, 7s, 5t, and a 5s squared. Are there any like terms there? Yeah, the 1s squared and the 5s squared, which is 6s squared. And that's all you can do. Simple, right? Oh, 10, we're going backwards. 12, right? 13. All right, Murphy's motorcycle gets 55 miles per gallon of gas on the highway and 45 miles per gallon in the city. The motorcycle holds 8 gallons of gas. Write and simplified expression for the total number of miles Murphy can travel if he has a full tank of gas, but uses 2 gallons on the highway and the rest in the city. Okay, so here's what they're asking. It's kind of a wordy problem. But highway is 55 miles per gallon, and city is 45, right? So if we do X gallons on the highway, how many gallons are left for the city?
It gives them from 2 gallons, it gives them
Right, it gives you 2 gallons, so what's the other?
8,
No.
6,
6. How'd you get that 6?
2 minus 8,
No.
8 minus 2.
8 minus 2, right? So if it's X, the other one's 8 minus X. Do you understand that? If I give you 2, you know it's 6, because you go right away and you subtract 2 from 8, right? But whenever I give you a letter, you guys I'm not sure what to do. Make it Y or Z? No. Just subtract from 8 the total. So here's what you're supposed to do. Write the expression 55x plus 45 times 8 minus x equals the total. Right? That's actually what you're doing, though, right? But most of you just put 55 times 2 and 45 times 6, right?
Yeah.
Okay? So, you know, this isn't worded the best, this question, but you should do that, which is, what, 360? So when it says write and simplify an expression for the total number, that's this write and simplify the expression. But then it goes on to say, if it's got 2 miles or 2 gallons on the highway, then you could just do this. But what most of you probably did is this, which is correct, but that's not really what it was asking. but I would give you credit for it, because you're still doing the right thing as far as figuring it out. Isn't that what you guys did, probably?
Yeah.
Yeah. Okay, but this is what it's really asking, but like I said, it's not a well-worded problem. It's one that I got from the book. That's what they were wanting you to do. And then plug the 2 in for x there to find the 380 instead of doing the 2 and the 6 there. But either way is correct, so I would give you credit. Okay? Questions on that? All right. Halfway done. Number 13. Expanded form means just write out what it means with these exponents. So, there's only this one negative there, and then there's 3 of these negative 3x's. That's what that exponent tells us. So when you expand it, they want you to write it out long ways. And squared, or 2 of those, just write 2 of them. So that's what we're looking for in expanded form. You don't have to simplify it or anything else. But I know you guys could, right? Now 14, you have to simplify. Okay. So, what do we do when we have a negative exponent? What happens to this number? Reciprocal. Very good. What happens to the exponent then? Positive. What's anything to the 0 power? 1. You guys are so smart. What's negative 1/4 to the 3rd? What's 1 times 1 times 1? Negative 4 times negative 4 times negative 4. So that's what we're looking for. Number 15. Negative 7a squared. So we got to square that. Then a squared b, we got to raise to the 4th power. All right, so negative 7 times negative 7 is 49. A times a is a squared. A squared times a squared times a squared times a squared means to multiply 2 times 4. And b times b times b times b, 3 to the 4th. And then 49 times 1 is 49. 2 a's and 8 a's is 10. And 4 b's.
Really?
Making sense? Okay. Now, for 16 with scientific notation, it's okay to have a negative exponent in your answer. That's the only time when you got scientific notation. So all I do is do 2.44 divided by 2.15. 1.134, 1.3, not 1.3, is it? It is 1.3, sorry. 134, was it 8, 3721. What do I do with the exponents when it's division? When it's scientific notation, it's always top minus bottom. What's negative 9 minus a negative 1? Negative 8. Going to add 1, right? Minus a negative 1 is adding 1. 17, the x column, 1, 6, 0, negative 9 is your domain. And the y column, 3, 13, 0, negative 17 is the range. That's pretty easy, right? 18, the top row is your x's. The bottom row is your y's. Is that a function? Yes. If I switched it, if the bottom row was the x's and the top rows were the y's, would it be a function? No, because we'd have a repeat. That 66 would have 2 different y's, right? Questions? Autumn?
So for you, you have to write that whole number off.
One whole number out.
15.
16? Yes. Just put it in your calculator. Write it all out.
So you can't just do
No.
around it.
Nope, don't round it. Write it all out. That's why you use your calculator, right? Make it easy on yourself. Number 19, does that pass the vertical line test? No. Remember to identify 2 points. I just used the 2 points on the y-axis. 0, 4, 0, -4. But you could use whatever, -2, 2 maybe? It's kind of hard to tell without the graph paper, right? 20, you're just substituting -4 in for x. So 2 times -4 is -8 minus 12 is -20. Good for 17 through 20. Those are all pretty easy, right?
Easy.
21, make an XY table. Or f of x. I just use these 3 numbers. You guys know you can use any numbers you want, right? What makes them easy? David?
So remember yesterday that I was going to a half, and you said to make it easier on you.
Right, I would, if it's a half, I use -2, 0, and 2. If it's a third, I use -3, 0, and 3.
If you don't notice that, is it okay?
Yeah, it's okay.
All right,
It just
it just makes it hard.
makes a little more work for you, that's all. So, what is our -2x minus 2? So, -2 times -1 is a +2 minus 2 is 0. -2 times 0 is 0 minus 2 is -2. And -2 times 1 is -2 minus 2 is -4. So -1, 0. 0, -2. And 1, -4. There you go. Okay. And then the last one, just put them in the right order, littlest to biggest. The smallest is the only negative one, -5/8. And then what's next is the decimal, 0.7854. What I would do is write them all as decimals so that you could see. Number 3 is the square root of 7, which is 2 point something. And then the +4, the integer, whole number. And then 2 pi, 2 times 3.146.28. So that's the order. Don't put them in the biggest, littlest to biggest. Do what it says. Hannah?
Can you say the order again?
-5/8, 0.7854, square root of 7, 4, 2 pi. Anything else? Will tomorrow's tests look much different than this?
No.
No, I'm not going to try to trick you or anything. Okay? So just keep practicing. Maybe practice it again.
That's what I'm gonna do.
Or just look at it online so you don't have to do all the reading.
So, it was, so I don't know if I can look people I just didn't do that. I was hoping so, but I did now.
Good job.